Hello, everyone. Thank you for joining our webinar today, Nutrition Labeling Challenges, Decoding the Common Sources of Confusion. I'm excited to have Mollie Hammerschmidt here with me today, hosting the webinar. I am Amy Knock, and I will be moderating today's session. Before we begin, I'll let you know a little bit more about how this webinar will run. The webinar is being recorded and the slides and recording will be available for you within 3 business days. A short Q&A session will follow the presentation today to answer any viewer submitted questions. During the webinar, you can submit questions you have using the webinar sidebar menu. Select the questions tab, type in your question, then hit the enter key on your keyboard. Remember, you can submit questions at any time throughout the webinar. That concludes my brief introduction today. I will now pass the webinar off to Mollie. Mollie, you may begin your presentation.
All right, well, thank you, Amy. Hello, everyone. Thanks again for attending today's webinar. So as Amy mentioned, my name is Mollie Hammerschmidt, and I am one of our Analytical Services Managers at the Nutrition Analysis Center in Des Moines. So part of my role really is to hone in on nutrition labeling regulations and use that knowledge to kind of help support our lab as well as our client services team when handling customer NLEA testing, fax panel requests, and questions that we receive. So today's presentation is really catered to the common questions that we receive from our customers that use our services, but as well as some common questions that companies within the food industry as a whole have together. So we're going to go over 3 topics today, but the majority of the content will focus on serving size information. These really do make up the bulk of our questions from customers, but we're also going to take a look at some sugar, alcohol, and dietary fiber related information as they correspond with nutrition labeling. And one thing I'd kind of like to call out on the right-hand side, you'll see I have CP equals confusion point. So, on point with the title of the webinar. You may see this throughout the slides. I tried to call out things that were common points of confusion that I really want to touch upon. So later when you're reviewing the slide deck, you can go back and find those for easy reference. All right, so without further ado, let's just go ahead and get started with serving sizes. So serving sizes, how are they displayed on the nutrition facts panel? So you can see there I have an example on the right-hand side. We display them as a common household measure and a metric quantity. So you can see there the 2/3 cup, that would be reflective of the common household measure, and the 55 grams in parentheses would be representative of your metric quantity. So we're going to touch on this a little bit more in a bit and what they mean, but for now, just know that they're what's used to declare serving size on a nutrition facts panel. So the second piece here for determining serving sizes is called the RACC, or what the FDA uses. This is the reference amount customarily consumed. And the FDA uses this as, like I said, the basis for their serving sizes. What it is it's just a giant list of foods by group and category that have the associated reference amounts that they've determined as a serving size. And then they also provide example label statements that kind of give you some direction on how to express that serving size, and so you can get more of an idea there. Now, a couple things to note with the RACC. It was established prior to 2016, but with the overhaul and changes to the nutrition labeling regulations, the RACC was updated. They did add several new products, so you can take a look at that, but they did update some that were already existing. So if you go through that, about 20% of them have actually changed. And this is a confusion point the first confusion point that I want to call attention to. That's really important. So you can't just make up your own serving size without consulting the RACC. The RACC is enforceable and it's intended to be followed. So if you have a product right now that you haven't made a nutrition facts panel for, or if you have a product where you recently updated from the old to the new regulations, If you have not done so already, I highly recommend going back and consulting the RACC to make sure that you're in line with what the FDA is calling for serving sizes. Now, with this, you're not required to match the RACC exactly, but the FDA says that you should be as close as possible. One last thing on the RACC, these are actually not serving size recommendations. So this is a point of confusion as well, although not really called out on the slide. These are actually based on what the average American, these are actually based on what the average Americans actually eat today. So basically what the FDA did was send out surveys or, several different ways of collecting data to figure out what we're eating on a daily basis. So they're not saying that this is what we should be eating as a serving size. This is what we are eating as a serving size. And that'll kind of come full circle later when we discuss a little bit more. Okay, so I mentioned that there are the common household measure and metric quantity that's required to be displayed on the nutrition facts. And so what this is showed, you have your common household measure, which is basically supposed to be what consumers can easily understand. You should really be using familiar terms. It's something that, again, is supposed to be very easy for the consumer to determine what the serving size is. And so these can be reflected as standard or descriptive units. Standard is typically more quantifiable in nature, so you have like tablespoons, cup, fluid ounce, ounce. But when those are not applicable, you can also use descriptive units, which is basically just that. It's descriptive and not necessarily quantifiable per se. So that leads me into the metric weight, which is the second requirement, which needs to be expressed as either grams or milliliters. The metric quantity, the purpose of this and the purpose of providing them in tandem with each other is really to relate to the household measure and provide context and consistency. So it's really important if your household measure and your metric weight are seemingly unmatching, it might cause some more confusion for consumers. So take that into consideration. The metric unit, another thing that a lot of people don't know is it actually provides context for different foods that have different densities. So if you have 2/3 cup of a liquid or a liquid beverage or a soup, whatever it might be, and 2/3 cup of something else, that's obviously going to have a different metric weight because of the density of the product. So this kind of helps consumers compare and make their own determination. So. All right, and so we'll delve into the RACC a little bit more now that I've kind of given you what it is and what it looks like. I want to discuss some key points to consider when you're using it and determining your serving size. So at the top right hand of the slide, you can see an example that was taken from the RACC, which is the RACC product category for cookies and crackers. One thing here, and that's emphasized by the orange box that I have a lot of confusion around, is that the label statements column is meant to provide examples of serving size, but the wording can actually be changed. So we get a lot of clients that say, well, the RACC says piece, so that's what I have to use. That's not true. Piece is just a generic description. You don't have to use that. You can use what's most appropriate for your specific product. Another really important clarification is that most RACCs are in ready to serve forms or almost ready to serve, but it does include some dry mix forms. So when you say dry mix forms, you're thinking like a brownie mix or a pancake mix, something that you're gonna have to prepare or combine with other ingredients to make the finished product. So the clarification point here for what causes a lot of confusion is that if you have one of these products, for example, a brownie mix that needs further prep, your serving size should actually be the amount of unprepared product, so your brownie mix, to make one serving of the finished food. And so I've actually provided an example on the right-hand side, and this is someone that chose to do what's called dual column. You can see the serving size of the mix in the first column with the nutritional information, and then the as prepared version. So this would be a good example of a label that's in compliance for serving size. And then kind of similar to that is you have other unprepared foods where some of those might actually change greatly during preparation or cooking. So bacon or breakfast sausage is a really good example of this. When you go to the grocery store, if you're buying raw bacon Sunday morning to make breakfast, you're not just going to eat that unprepared unless you're buying the ready-to-eat bacon. And so what the FDA says is that your serving size for those products should be in the prepared form and state as consumed or prepared. And another good thing to call out with those is that you actually are required to provide the cooking instructions and preparation instructions on your principal display as well. All right, so now that we've gone through the RACC a little bit, I want to go through some examples of how you would determine this. And I think this is confusing overall to most, just the way that the CFR is structured and written. It's just not very friendly. So what I've done here and what the FDA does is they basically categorize into 4 or 5 different large categories of products, and you would determine where your product falls under that and then follow the rules to determine the serving size. So the first of that is a bulk product. So examples of that, you've got like your bag of sugar that you buy from the grocery store. It could be a box of cereal. I like to think of them as anything that like you can pour or scoop, something that's more in bulk in nature where you measure that out. So something here that's interesting is when you're determining your serving size, you would actually go and look at the household measure that's in the RACC rather than the metric weight that they provide. So whatever your product is, you would go look up what the recommended household measure is. If it's half a cup, you would go take your product, scoop out half a cup and weigh it, and that's your metric weight. So you're not determining the serving size from the metric weight they list, you're using the household measure to determine your metric weight. The next category is discrete large units. So something that's really obvious, these are supposed to be things that are divided for consumption. So a pizza is a perfect example. A pie is another perfect example. What the FDA says is that you would use the fraction closest to the RACC. So that can be halves, thirds, fourths, fifths, sixths, any of those denominators that can be divided by 2 or 3. An interesting thing to call out is that you shouldn't really use 1/7 as a fraction. The FDA kind of considers this as too difficult and not consumer friendly. When you think about it, I don't know anybody that divides their pizzas into 7s. I'm sure it can be done, but it's just not easy and not what we normally do. So just an interesting point there. And then, so to get a little bit more complicated, but this is where a large chunk of products that we provide nutrition facts panels for specifically fall, and that's under discrete individual units. So what the FDA has done is they've set aside these thresholds and percentage ranges of the RACC. So wherever your unit weight falls in those percentages, that's how you're going to determine your serving size. So again, when I mentioned before that you can't just pick your serving size, this is very applicable to these products. So we're going to walk through using a muffin as an example. So whatever muffin that might be, the RACC for that, if you look it up, is 110 grams. So using these percentage rules that the FDA has set out, if you're making a muffin that's 55 grams or less, that falls with less than 50% of the RACC. So you would use the number of units closest to that reference amount. So how do you do that? Your RACC is 110 grams. Let's say you're making a muffin that's 25 grams. You take your 110 and divide it by 25 and you get about 4 muffins. So your serving size would actually be 4 muffins. Similarly, if you're making something between, or the muffin between 50 and 67%, your options for serving size are 1 or 2 units. You cannot use anything else. You can't use 1.5, you can't use 2.5. You can't use 3, 4, 5, whatever it may be. Your options are 1 or 2 muffins. And then if your unit weight is 67 to 200%, and I think given the large range here, I think that's where the FDA expected most serving sizes to fall. So that would be a muffin of 85 grams to 219 grams. Your serving size must be 1 unit. You do not have a choice. That has to be your serving size. And then we'll touch into this a little bit more later again when we go into dual columns, but I did want to call attention to it. If you're making a really big muffin and it's greater than 200 but up to 300% of the RACC, you actually are required to label per serving as well as the total package. And again, I'll get into that when we go over dual columns and kind of explain more why that is the requirement. So before we do that, I'll just touch on one last determining serving size example that causes a lot of confusions for our customers, and that's units that vary in size. So a really good example of this is beef jerky. You go to the store, you buy a bag of beef jerky. Very rarely are they all uniform, same size. It's usually different size pieces because of the nature of processing. So that is okay according to the FDA. If you are making your serving size or your piece weight at consistent weights, so let's say all of your jerky weights are 2 grams, 17 grams, whatever, you would follow the percentage rules in the RACC. If that's not the case and they vary in size like a lot of jerkies do, the RACC actually says that you're supposed to use the amount in ounces that closely approximates the reference amount. So I apologize for the blurry example there, but I have a nutrition facts there you can see where if we look up the RACC for jerky, that's 30 grams according to the FDA. The closest ounce is 28 grams, so your household measure would be 1 ounce and your metric weight would be 28 grams. All right, so now we get into the fun stuff, which is the dual column requirements. Like I mentioned, they are required for units where the weight is greater than or equal to 200 and up to 300%. So the key point here, the whole point of dual columns is to make consumers aware of how much they're actually eating. So this is set forth because the FDA saw that there were a lot of products, usually between like 2 to 3 servings, that could reasonably be consumed in one sitting, whereas, you sit down and you just end up eating the whole package. So this is really what I think is the primary purpose for dual columns, is to make you aware of what you're eating. So remember that really big muffin that we had, you go to the store, get that for breakfast, and you look at the nutrition facts panel. Well, you could reasonably eat that one muffin in one sitting, but the FDA wants you to know that there's 760 calories in that muffin, along with all the higher levels of fat and whatnot. So you can see in the example there, that's what it would look like. So another clarification point and confusion point is that you actually do have the option to use a dual column. So if you're making, maybe a slightly smaller muffin and you're using, you've got some no sugar added claims or whatever, and you want to use a dual column to kind of display that your product has less calories or maybe use it to your advantage, you can do that as long as you're making a single serving container that's between 150 and 200% of the RACC. Typically, the requests that we get are for those that require dual columns. So obviously, with every rule, there's an exception. So there are dual column exceptions. The first being tabular and linear labels. So any product that requires or meets the requirements, I should say, for a tabular or linear label format does not require a dual panel. So when you think tabular linear labels, that's usually indicative of limited total surface area that's available for labeling. So it really, if the product is that small, the theory is probably that the product wouldn't bear significant nutritional content in general, and thus consuming that whole thing wouldn't be incredibly different. So those do not require the dual columns. Raw fruits, vegetables, and seafoods, so the stuff that has, you know, voluntarily or voluntary labeling available, you do not have to use a dual column for those. If you remember our jerky example that we just talked about, so anything with varied weight products do not have to have this as well. And in thinking about that, so the reason this is that containing 200 to 300% of the RACC wouldn't necessarily be consistent across the board, so that's why it's not required. And then the last category on this slide, which is really kind of composed of subcategories. So a product that's already bearing an additional column on the label does not have to have a dual column, or really in this case, it would be a tri-column. You wouldn't have to include a third column for that as the entire package nutritional. So anything that's going to have the as prepared or as packaged column added, you go back to our brownie mix earlier, that would not have to have a dual column. And then products that are commonly consumed with another food and provide an additional column for the combo. So a really good example of this that probably most people have seen if you eat cereal is cereal and milk. So if you look at your nutrition facts on those, a lot of them do provide the serving size of just the actual cereal itself, and then they do provide the nutrition information with a half cup of milk. A couple more that aren't listed, but worth noting. So if you're making a label that has different RDI groups or reference daily intakes for different age groups, you do not have to do a dual column for those. And also popcorn products. So if you're already adding a column for the popped versus unpopped nutrition information, you also are not required to do a dual. All right, so the next slide, I am not going to go through this, but I did want to include it so that if anybody goes back through the slide deck, it's there for reference. Earlier I mentioned standard and descriptive units are used for serving size. This is basically just an outline of what can be used for what type of products and what the FDA recommends, and also really when you should be trying to use standard units instead of descriptive units. So this is included in the presentation for later, so if you do have questions, feel free to reach out. And then the last thing for serving size or serving size related information that I want to touch upon is the servings per container. A good confusion point that we see a lot is whenever you're rounding your servings per container, you should really be using the term about. And when you round to your servings per container, you should be rounding to the nearest whole number. Now that is except between 2 and 5 servings per container. So you can actually use 0.5 or half increments between 2 and 5, but one thing that we see all the time when making nutrition facts panels and requests from customers is to use half increments on servings per container that are outside 2 to 5. You absolutely cannot do that. You have to stick to the nearest whole number. So I've actually put a chart on the right hand side that we've provided to our team and that I actually find helpful too. It just helps you kind of determine where you fall and what serving size or servings per container, excuse me, that you can use. And the last point here that some don't know is you can actually use the word varied for random weight products that vary in size. An example is that third nutrition facts label I've got there. I think of things like chicken breasts that you buy from the store where it says varied servings per container, but also gives you the ounce weight and the gram weight. Sometimes those are different. The breast pieces are not always the same, so you may get 2 or 3 or 4 in that package. So that's why you're allowed to say varied. All right, so now that we've talked about serving sizes, I'm going to go ahead and move into sugar alcohols, and we will go ahead and start by what they are. So Sugar alcohols, for those that don't know, they're carbohydrates, but they have chemical characteristics of both sugars and alcohols. They don't contain the same type of alcohol found in alcoholic beverages. That is different, but they are chemically, they exhibit both of sugars and alcohols. So where do we find these? You can find them in some fruits and veggies. A good example that comes to mind is aronia berries have naturally occurring sorbitol, which is a sugar alcohol. But for the most part, for the products that we see or create labels for, they're usually commercially produced sugar alcohols made from sugars and starch. So the confusion point here that a lot maybe don't know or don't quite understand, sugar alcohols are only partially digested by the body. So they actually contribute to a lower caloric value, which I'll get into here in a minute. Okay, so where can you find these and what do they do? You will see sugar alcohols in a variety of different products, but the main ones are, baked goods, chewing gum, any type of dessert, those types of things. And what they do, so they have a lot of different functions. They can add bulk and texture. They can prevent browning when you're baking. Kind of a cool one is they produce a cooling sensation in the mouth when they're added at high concentration. So chewing gum is a really good example of that. If you've ever stuck a piece, or if you're like me, if you take 3 pieces of sugar-free chewing gum, next time you do that, take a look and see if there's sugar alcohols and if you feel a cooling sensation, because that's likely where it's coming from. Another neat thing that doesn't really relate to labeling, but kind of relates to the appeal of using them in products. Sugar alcohols actually don't react with the plaque bacteria in your mouth, so they can't and do not cause cavities like traditional sugar would. And then the biggest function or appeal for using sugar alcohols is that they do help you support sugar-free claims, and then they contribute less calories. So the reason this is sugar alcohols are, as I mentioned earlier, they're incompletely absorbed from your small intestine into the blood. And so that's why they produce fewer calories, and they actually produce a smaller change in your blood glucose, which is your blood sugar. So there's actually been quite a bit of discussion about including sugar alcohols in the diets for diabetics, because they can be converted into energy with very little help from insulin. So that's kind of a neat thing there. They do have some disadvantages. So if you are using sugar alcohols in your product in high concentrations, specifically those mannitol and sorbitol have been known to cause like bloating, gas, especially in large quantities. And that's because, like I said, they're not completely absorbed. So when they get to your large intestine, they're actually fermented by the bacteria, and that's what causes the bloating and gas and diarrhea. So if you are adding sorbitol or mannitol, be sure to include the label warning statement. It's something like excess consumption can have a laxative effect. That needs to be included on your principal display. And then the last piece here, the confusion point is because, or even though that they do contribute less calories and support sugar-free claims, sugar alcohols are still very much carbohydrates, and they have to be reflected as such on the nutrition facts panel. We do see a lot where customers ask us to remove them from the carbohydrates along with the caloric reductions, and that just can't be. They are still very much carbohydrates and contribute. Okay, so then to talk about the labeling portion of it, you can see on the right-hand side, we have an example of where the sugar alcohol content would be displayed, which is indented under your added sugars there. So important to note here, if you're adding sugar alcohols to your product and you are making a statement or a claim about the health effects, so whether that be no sugar added, sugar-free, reduced sugar, whatever, you have to declare your sugar alcohols. A confusion point though is if you are adding sugar alcohols but not making a claim, which we do receive a handful of those products as well, it's still really important, and I say this to advise for those of you who haven't had your products tested yet, or maybe have already had them tested too. You should likely talk to your testing lab about running a sugar alcohol profile in tandem with your sugar profile. And the reason for that is specifically for those of you who are adding sugar alcohols but not making any claims. Our lab in Des Moines uses a universal detector, an ELSD detector. So there is a good potential for the sugar alcohols to actually interfere with those sugar peaks, and thus we would quantify them as sugar. And that's definitely not what you want. So some known interferences I've listed there: maltitol with maltose, lactitol with lactose, xylitol with fructose, and then your mannitol and sorbitol with glucose. And then, as I mentioned earlier, you've got your standard caloric contribution of a normal carb is 4 kcals. You can see on the right-hand side there, this is because they're partially digested by the body, their reduced caloric contribution is about half for most, maybe a little over for sorbitol, but erythritol being usually the most appealing is at a 0 kcal per gram contribution. So we do see a lot of nutritional or products submitted for nutrition labeling that contain erythritol. One thing that's listed, or not listed on this slide, I should say, but that many don't know, if you're only adding one specific sugar alcohol, you can actually call out that specific name in your facts panel. So where I have sugar alcohol 0 grams, if you're only adding erythritol or you're only adding sorbitol, you can replace that nomenclature with the specific sugar alcohol name. But if you're adding more than one, you can't do that, and you would just have to list sugar alcohol. All right, and so now we're just going to go ahead and move into our final topic for today, probably the most fun for some, which is dietary fiber. So we'll start off by going over what is the current definition of fiber, or AKA the 2016 definition. This causes so much confusion for so many people, including myself some days. There is just a lot of literature out there, conflicting literature, but also just the terminology used is kind of unfamiliar to most people, and they may not understand it. So I'm going to do my best to explain the definition to you guys as I understand it, and it's broken up into 2 parts here. So the first, being the most obvious, is your non-digestible, soluble, and insoluble carbs and lignin that are intrinsic and intact plants. So again, naturally occurring fiber, it's often referred to as those bold words I've got, intrinsic or intact. And that's going to be like your whole grain, cereal bran, lentils, oats, and those are considered to be intact because they haven't been removed from the food. They're natural. So those are the obvious ones. The second part of the definition, which is the part that causes most people confusion, is the isolated or synthetic non-digestible carbohydrates determined by the FDA to have beneficial physiological effects. There are several things I want to discuss here. The first being the term isolated. It is defined in some of the FDA guidances, but nonetheless still confusing. When I think of isolated fibers, those are what are crystallized, concentrated, solvent extracted. They're not in their natural form. They've been processed. You've done something to remove them from the plant, maybe increase the concentration, things like that. Those would be considered isolated. So you think to yourself, like a good example of one that causes a lot of confusion is pea fiber, right? So you think peas are natural, so the fiber is natural. No, that's not how it works. Pea fiber can come from many different sources of the pea. So you've got the seed hull coat, which would contribute a different type of fiber than something like the inner pea fiber, which is the cotyledon. So like inner pea fiber is a really good example of something that would be considered isolated or synthetic and not natural. So there are a lot of examples of these, and I'll kind of touch on pea fiber again at the next slide. But it can be very confusing to determine what's natural and what's not. So think fibers that are processed and not in their natural form. The last thing on this slide I really want to talk about is those that are not listed in the CFR, or for which FDA hasn't come out and gave us a guidance saying that they're going to allow enforcement discretion, are not dietary fiber. I really want to emphasize, so if you have, let's say you're making a product and you're adding a fiber and you have several studies and data that show physiological benefit, that's not enough to include it. You have to file a petition to the FDA and get approval for an exemption. Just because you have the data to support it doesn't mean that the FDA considers it. They have to review that data and make that determination themselves. So very important. So what are the official list of approved fibers? A lot of times people struggle with this just because they're not really all grouped in one spot on one web page or one guidance. So I thought it might be nice to just include a handy chart that lists them all. So May 2016, that was when the final rule was established, and they came out with the first 7 isolated synthetic carbs that meet the definition of fiber. So you can see those there, and then after that list came out, several people submitted petitions because they were using other sources of fiber and wanted them to be declarable. So the FDA reviewed that data, and in June 2018 came out with 8 more fibers. Now, important to note here is that the final rule actually hasn't been amended to include these, but the FDA is saying that for now, you can label them as fiber. And they're saying that because they intend to include these in the amended final rule. But just an FYI, 2019 and 2020, we had 2 more additions to that list. So the cross-linked phosphorylated RS4 and your glucomannan. One thing to talk about here that causes so much confusion is what the heck is a mixed plant cell wall fiber? That's confusing to most, and rightfully so, because it can be a lot of different things. So specifically, the FDA is considering them to be ingredients that have 2 or more of certain plant cell wall fibers, and those are cellulose, pectin, lignin, and beta-glucan. So if you have 2 or more of those, it's generally going to be a mixed plant cell wall fiber. And the FDA, in their guidance, it's not obvious. So if you're going through the main content of the guidance, you won't see it there, but in the footnotes, they call out an incomplete list of examples of these. And so pea fiber, which we just talked about, is actually one of them. But as I mentioned before, you have to be really careful because pea fiber can mean so many different things. You could have the pea hull fiber, you could have the seed coat, you could have the intercotyledon. And so, in that fashion, some of these plant wall fibers, like pea fiber, are actually subject to different types of processing. So the name of it may actually not be indicative of whether or not it's intrinsic or intact. Not to mention, so there are also types of processing now that are used that can result in different degrees of isolation. So again, the FDA is saying that they're going to allow these, but they're going to exercise enforcement discretion, which I find to be very vague. So in my opinion and recommendation is, if you're using any of these, make sure you have the data to support it. Maybe proactively file a petition or reach out to the FDA because you don't want to be caught in a situation where you're declaring more fiber than actually is there. It's one thing to underestimate your fiber, but it's more significantly detrimental to overestimate your fiber. So then just to kind of expand, you've got the list now with the official approved fibers, some that we receive a lot of inquiries about, or if they are allowed to be included: carboxymethylcellulose, gum acacia, xanthan gum, things like that. Those are not considered dietary fibers. So if you're sending a product to be tested, or you're determining your nutrition facts panel based on ingredient formulation, remember to subtract out the fiber contributed by those ingredients, because it's not included in the definition. And again, you would be overestimating your fiber, and that would get you into some trouble. Okay, so for the last piece that we're going to talk about when it comes to fiber is the caloric contributions. Same as sugar alcohols, they are carbs, and carbs contribute to calories. I've got the formulation there. You can see, like I mentioned earlier, your standard multiplication factor for the carbohydrates is 4. The FDA has now said that beneficial soluble fiber can be 2 kcal per gram, and insoluble can actually be 0 kcal per gram. So that's really beneficial for those that are making fortified fiber products, things like that, get your calories down. The only exception to that is in 2018, the FDA proposed that polydextrose be an exception. So they would actually be 1 kcal per gram if you're adding polydextrose. And so the most important thing that I think from a laboratory standpoint to call out here is if you are, making these fiber fortified products, or, you're interested in applying the caloric reductions based upon the fiber that you're using, we have to know, or you have to know, the insoluble soluble breakdown to apply those calorie calculations. So if you're using a reference database, it might already have that information, but if you're having a testing lab perform the testing for you, I know our lab in Des Moines, as well as many others, default to a total dietary fiber method. And so that total method is just going to give you that. It's going to give you the total. It's not going to tell you what's insoluble and what's soluble. And we have to know that in order to provide those calorie reductions. So just keep that in mind when labeling and sending products for testing. And so with that, that is all that I had for you guys today. I know it was a lot of information, but as Amy mentioned, we'll have a Q&A. I'm happy to answer questions. And for anything that I can't answer today or want to follow up on, my contact information is at the bottom of the slide there.
Wonderful. Thank you so much, Mollie, for your presentation today. I'm just going to launch a poll here. So if anyone would like us to follow up with them after the webinar, if they have any questions, certainly submit yes to that, and we will follow up after that point. So again, I've had a few questions come in, just housekeeping items. Again, as a reminder, we will send out a copy of the slide deck as well as a recording of this presentation within 3 business days. So, that covers that one. I think that there's a couple questions here now that have come in to the chat. So the first one here for you, Mollie, is I've seen products on the market that only list a metric weight as serving size. Are you required to list both the serving size and common household measure, or can you just list the metric weight since it is the most accurate representation?
Yeah, so that is a really great question. We do actually receive a lot of requests for just using the metric weight, but you actually should be providing both. So the notes within the RACC specifically say that manufacturers are required to convert the reference amount to a label serving size in a household measure most appropriate to their specific product. So technically, you cannot just be using the metric weight. You should be going back and determining a common household measure.
Okay, great. Thank you. The next question that we have in here says the FDA's guidance only lists RACC for pizza crust. How do you determine the RACC for the pizza and sauce and toppings? Is it the same as the RACC for the crust?
Okay, that's another really good question. So yeah, if you have a product like a pizza or something where there's multiple components, you would actually go to the RACC and find all of the components recommended amounts customarily consumed and add them together, and that would be your RACC. So for something like pizza, you would take the pizza crust, which is like 110, and then you would go find, I believe it's called minor entree and major entree additions. You'd go to the RACC and find that and look for, your pizza sauce or your toppings and your cheese. And you would take all of that and combine it together, and that's the RACC for pizza.
Great, thank you so much. And I'm monitoring the questions here. It looks like we have one more that came in. The question here is, are sugar alcohols included in the available carbs claims?
That is a good question and one that I'm not sure of. So I'd have to probably take a look at that further to address. So if whoever posted doesn't mind, I would be happy to look into it further and follow up with more information on that one.
Wonderful. And we have the person who submitted that question. So again, we will respond to you offline to get you a response to that. But it looks like there haven't been any other questions that have come in. So that would wrap up our Q&A session. And again, I want to remind everyone that a recording of the webinar and a copy of the slides will be available within 3 business days. And again, thank you, Mollie, again, for your expertise and your presentation today. And thanks so much to everyone for attending.
Thank you, everyone. Have a good day.
Thank you.